All right. Okay. Good afternoon, everybody. Good afternoon, good morning, depending on where you are. My name is Charles Nebeze, and I'm the Vice President Business Development with the Center for Excellence in Mining Innovation. And today I'm very pleased to be hosting this webinar by the Lost Dutchman Mining team. And today's presentation is on sustainable water-free ore concentration technology. And, you know, we move so much material in mining that, you know, anything we can do to reduce the amount of material that we're moving from point A to point B would significantly decrease the amount of costs associated with mining. And I think more importantly, you know, if we can actually enable that ore sorting or concentration to happen in a way that doesn't use that precious resource water, you know, that would be a very good day. So today, the Lost Dutchman Mining Group is going to be speaking to us about a sustainable, water-free ore concentration technology. So without any further ado, I want to hand it over to Kenneth. Go ahead, Kenneth.
Thank you, Charles, for this opportunity to showcase our process through CME. Wayne Rod, Mark Ogram, and myself, Ken Abbott, are the partners of Lost Dutchman Mining, and we've developed this technology to separate particles of one specific gravity from another. We also have with us today Dale Shea of Rimcon LLC, a mining consultant, who's become one of our team members during the course of this process. Our technology was actually developed quite a few years ago and has been in use successfully since about the mid-90s for customers in industries other than mining. The use for mining was evident when we first developed this process, but at the time we developed it, the mining industry wasn't all that interested in the process. There wasn't quite the pressure to conserve water. It certainly isn't what it is today. And we at LDM still think that this is part of the best use of our technology. So without further ado, we'll get into this. These are essentially the three general categories where we believe our process can benefit the mining industry. They're highlighted on the slide: significant water reduction, significant chemical reduction, and significant reduction in material handling, predominantly with regard to haul trucks that have to leave the primary mining site to haul pre-concentrate to a remote processing area. Our process can be used in several sectors of the mining industry, but the ability to manage tailings and waste material, as well as significantly reducing the water requirements, we think are the key components of our process. As an example of what we believe we can achieve with respect to water conservation, it's estimated that mining today uses approximately 26 million gallons of water per day for various processes. We believe our process can help reduce that consumption by anywhere from 50 to 80%, depending on the application and the existing process requirements. We hope to illustrate briefly in this presentation the basic operation of our process and how it can reduce the cost of doing business in mining. We won't be going into specific details, but we'd be happy to discuss that with anyone that's interested in a specific application. This diagram illustrates the basic components and their place in the process. AMO is just an acronym we use internally to indicate our controller position, and it really doesn't have anything to do with this presentation. The system would typically be inserted in a typical ore processing line between a crusher and a ball mill. The crusher would simply unload into our load hopper, which would then take it through our process. Components of this process would differ from application to application, but essentially they're all the same. And we would offload into a hopper that would then feed into our process ducting, and the concentrate from that at this area, at this point here, would then be set to further processing, whether that's flotation or whatever the process may be. The advantage here is the mineral concentrate, or what we're going to call pre-concentrate, that goes to that final process will be substantially less in volume. Hence, the water savings in your flotation, for instance, and the chemical savings. The benefits of our process for various minerals, different types of minerals, is shown in this slide, and our partner Dale from RIMCON will explain this in a little bit more detail. Dale, you want to take this?
Well, thanks, Ken. As Ken has already noted, the technology is an ore sorting or pre-concentration type technology, where the ore will be concentrated prior to going to the final process facility. One of the advantages of this is a waste rejection prior to going to the process facility. You're sending far less material to the process facility, and that has several advantages that I'll talk about more on the next slide. There's several types of ore concentration technologies out there, including Nelson concentrators, centrifuges, and so on. And we believe the LDM technology has several significant benefits over those types of technologies. It's a sensor-based technology. As Ken will probably talk about more, the control processes on this system are extremely sensitive and efficient, making it for a very useful tool for concentrating. The biggest advantages have already been mentioned on this over other technologies. There's no water needed to do the concentration with the LDM technology. No chemicals are needed. And I think one of the big advantages over a lot of other processes is the LDM technology will separate both free gold and refractory gold. Next slide, please. We've talked quite a bit about the operational benefits, but of every bit as much importance to mining companies now are sustainable benefits. And these sustainable benefits include environmental, climate change, tailings management, and water management type benefits. The left side of the chart here are several ore types: sulfide ores, oxide ores, and carbonaceous or limestone-based ores. And these ores are all able to be concentrated through the LDM process. The sustainable benefits that come out of that, Ken has already mentioned a significant reduction of haul truck loads that go from the crusher to the process facility. While these have very important operational benefits, it also is significant in that you will have a reduction in greenhouse gases. That's something that for climate change people are looking at pretty hard now. We've mentioned several times that there's significantly less processed water that will be needed to process a concentrated ore, and significantly less chemicals that will be needed to process the ore. And again, those are also sustainable benefits that are talked about within mining companies in the private sector and stakeholders alike. Fewer vats or flotation tanks are needed in this process. If you're building a new facility, you can lower your infrastructure costs by not needing as many process facilities. If you're going to use this technology at an operational facility that's already built, then you have the advantage of looking at increased throughput through your facility because you'll have more tanks available. By taking the waste out prior to going to processing, then you end up with significantly less tails that go to your tailings impoundment, and it'll take less water to send those tails to your impoundment. Both of those are big issues in terms of sustainability and tailings management. Our process will significantly reduce the amount of those things that go to your impoundment. And finally, there's a beneficial waste rock usage. If you're taking that waste out before going to processing, that waste rock can be used for other uses, such as pit backfill, road building, and so on. So it has some operational and sustainable benefits there. Limestone waste, if you separate the limestone from the ore prior to going to processing, then you can use that limestone rock for remediation efforts, whether it's for treating tailings water or acid tails or acid waste rock. That rock is available for that purpose. The technology was developed on dry tails, historical dry tails, with a lot of success. And by reprocessing tails, you may have an advantage of additional revenue sources at your mine site. I'll turn it back to you.
Thanks, Dale. The slide you're looking at now displays a diagram that illustrates the potential in an optimum application of the transportation cost reduction possible with the LDM process. This is admittedly an extreme example, but several of our test results indicate it is indeed possible, given optimum conditions, optimum ore type, and so on, to achieve these types of cost reductions, essentially going from 100 trucks to less than 10. Again, this is relating to sites where, you know, your ore is going from the site essentially to another location for processing. Obviously, this wouldn't be quite as important on a site where you're going to haul your ore and go directly into the mill. But even in those applications, we think we can offer some transportation cost savings. It's our expectation that once adopted, we can help our customers achieve both environmental sustainability and fiscal improvement, which can help them do their part in slowing the climate change. It was discovered during our testing that the process is actually pretty linear. While most of our testing for the results, especially the ones we have shown in this presentation, was done in our lab unit, we also found that both our pilot plant operation, which we'll talk about a little bit later, and a third unit we tested just to confirm our expectations, had a potential material throughput that's essentially relative in proportion to the size of the separation duct that we use, the separation duct diameter. So using data from those three units, we've estimated throughputs between 132 pounds per hour to just over 59 tons per hour. Although these numbers are all theoretical, we believe that with proper equipment, they are in fact achievable. This model shown is a conceptual design of one variation of our system using a 4-foot diameter separation duct. If we go back one slide and look at the that one we just had, no, maybe I'm not, there we go. Oop, lost it, sorry about that. You'll see that the 4-foot duct diameter is theoretically capable of processing 4,750 pounds per hour of rock, and the three highlighted sizes are the sizes we've actually operated and confirmed these throughputs in a typical operation. This model just shows a conceptual array of three of those 2-ton per hour systems using the 4-foot diameter separation duct. This provides a theoretical 6 tons per hour, and it could either be set up to process one specific particle size, or you could send 3 different particle sizes to each unit for a 2-ton an hour separation capability, pre-concentration capability of a broader line of your material. So you'd be processing 6 tons an hour of material, but across a broader spectrum of particle size. During the years of testing ores from various mines, we also had the opportunity to try it out on various types of, oop, I lost something. What happened there, Charles?
You seem to be fine from this end. What did you lose?
I lost the whole thing.
Okay.
I don't know if you see me, but I think I've got your email.
Yeah, I
I
do
think
see. I do see your slides.
I'm looking at your email.
Okay.
Let me see if I can get out of it because I lost my slides. I have no control over my slides.
Oh, okay. Okay. Maybe just use the Alt tab on your machine to go
Yeah,
back to the
I
screen.
think that's your email. Yeah, I've got your email on my screen somehow.
Okay.
Sorry about that.
Maybe use the arrow down key to see if the slide will go down. Okay.
I can't do. Oh, there we go. I'm back.
Thank
I
you.
don't know what you did, but I'm back. Okay, sorry about that, folks. Technical difficulties there. As I was saying earlier, during the years we tested ores, we had an opportunity to test other materials, and some of them included things such as types of plastics that people needed to get contaminated, denser contaminated material out of. And we also did some work with some recycling in the electrical field. That included this this material that we got from a company that they recycle chips, basically chips from computers. Those little bricks, and those things contain, besides the resin and the silicon that all the components are housed in, the circuits actually have a fair amount of gold and precious metals due to the conductive properties. And we were able to successfully liberate free gold from this resin silicon matrix with very little effort. That was quite easy and did not require a lot of sensitive adjusting. And this is a magnified view of some free gold particles mixed with the black silicon resin that the chips are made up of. This is from one of the tailing sites. It's one of our early samples. We were able to liberate both some free gold right here in the middle, as well as some refractory ore. And we were able to effectively separate that from the waste gangue that we collected at the old tailing site. In this chart, we show the results of 19 various samples that were taken over a period of time from an abandoned mine site. All of these results were confirmed by assay conducted by Copper State Analytical Labs of Prescott, Arizona. They are a certified, or were at the time, a certified assay lab. They unfortunately closed here about a year ago. But they were one of the few certified labs in the state of Arizona. And we wanted to use a certified lab so there'd be no question about the veracity of our testing. The chart and the one following, they show target mineral concentrations in grams per ton, both before and after concentration in our system. You can see in this one, in test 8, for example, over here, that our beginning concentration was 0.567 grams of gold, or about 0.01 ounces of gold. The concentrate that we came out with afterwards assayed at 17.6 grams per ton, or about 0.6 ounces per ton of gold. That was a 31-fold increase in target ore concentration. You can see some of these other ones were spectacular, but that sometimes happens. And I think of more importance is what our averages seem to be over a broad spectrum of various samples. Our silver concentration achieved similar results. These are from the same tailings. We had them both assayed at the same time for gold and silver. And in some cases, we got even better concentration results with the silver. we're not going to go into a lot of detail about the pilot plant operation in this presentation, but we thought it'd be helpful for viewers to see an actual system set up in an outdoor environment. While we know it's not an optimum setup for our process, we needed to know if it was possible to operate one outside. And if it was, how successful would it be? We wanted to find out, what are some of the problems going to be? And we used this also to confirm our linearity that we expected to see. This was the one set up with the 24-inch diameter separation duct that was shown in that the slide earlier. So this is the mine site. It's a remote site, an abandoned mine in central New Mexico. The hill over to the left in this area of our site was an old tailings pile, and we used that for some of our test samples. We took them out of various spots in that tailings pile, not all from the same spot. In this closer view, you'll see the equipment trailer here, which housed a small lab in the back here, and our process control cabinet was inside. The components that we have outside here that you can see includes a dust collection unit up on top, and a generator down here to power the unit. We were completely off the grid here. And then we had some fuel drums to keep the generator going. We were here for about 3 months, doing in late fall, late summer, I'm sorry, late summer through the fall and into the beginning of the winter. And it was a very interesting operation. Due to our filtration efficiency here, the air from our exhaust process ends up being actually cleaner than the surrounding air. This site was located at about 8,000 feet in altitude. So as I said, we were on site for several months, during which time we discovered many issues associated with outside operations. Among the most important was the need for dry ore stock. The problem we encountered very early, although when we were digging our pits and getting our stockpile set up, the material looked dry enough. What we found was it was in fact still quite moist and did not want to flow very well. So we had to rig up our dryer, which we fabricated for the most part on site. Some of this we had fabricated in our factory back in Tucson and shipped, but most of this was assembled and all designed on site. It's a combination screener dryer. We've got 2 sizes of separation screens, and then a dryer, which you'll probably see in the next slide. You'll see how we rigged up a small drying system. So here's our sophisticated dryer. It was crude, but it worked, and it allowed us to actually really get some processing going. We were processing at the rate of about 1.5 tons an hour through this unit. It wasn't optimum, but we were able to do it. We have a grizzly type loading hopper that empties into that screener dryer, and from there it's fed in through a system of ducting and so on through the components of the system into the unit inside where we have the separation system. While the mining industry has been a little reluctant to explore our technology, with the emphasis on the environment and the reduction in both water and chemical use, combined with this relatively new environmental and social governance movements, we now believe we have something to offer which wasn't previously recognized. My partner, Wayne Rod, will add more about these advantages. Wayne?
Good morning. This slide is one I wanted you to see just to get an idea of the tremendous amount of money that ESG investors control. And I just took the market cap of the 10 largest mining companies to show kind of a comparison. But ESG, environmental, social, and governance, has become the catchword for these guys. And these people, these investors, are being discussed at the CEO level and the board level of not only mining companies, but all kinds of other companies around the world. Ken, will you flip to the other slide?
Certainly.
I think that the industry is going to have to consider the growing number of ESG investors. These folks have an investment strategy that, one, they look at financial returns, but secondly, they look at social and environmental responsibility. And I think that they're going to become an increasingly significant source of funding for the mining industry. Interestingly enough, currently, a lot of the ESG funds exclude mining investments in favor of what they consider cleaner sectors. And it's kind of an interesting issue because the mines issue sustainability reports that are really pretty well written, cover a lot of ground, and yet there's still some friction on the part of ESG investors against investing in the mining industry. We believe that our technology can help the mining companies reverse that mindset. For example, in reading through some of the sustainability reports that the mines issued, you recycle and reuse a lot of the water that you're currently using. If you can cut that water use 50% and then recycle the remaining water that you're using, I think you have a clear winner. And more importantly, I think you have something that can be presented to ESG investors who are looking for real results that can be easily verified. And I think that's one of the issues with sustainability reports right now, is they're well written, but in an evidentiary sense, they fall a little short from an investor's point of view in trying to say, this, I can really verify this very easily. And we think with the adoption of our technology and the reduction that can be obtained in water usage, that the kind of evidence that these investors are looking for can be easily provided to them. Ken, back to you.
Thanks, Wayne. This shows we had a confirmation and validation of our process some time ago. It was conducted by CONCEPTUal Research of Richmond, British Columbia. And it was done at the request of Dale Shea of RimCon, who's with us today. And he had several clients that needed a process like ours, but they first wanted confirmation that it was a valid process and not just a bunch of smoke and mirrors. Dale contracted with CONCEPTUal, who subsequently conducted visits and created a test criteria for our process. Some excerpts from these investigators' summary follow, but Dale can make the entire report available upon request of proper documentation and some NDAs from anyone that's interested in seeing the whole report. It may even be possible at this point in time for an interested party to contact the actual investigator if they wanted to follow up, but we would have to clear that with him. I've taken the liberty of taking excerpts of the summary. The report itself is several pages long and wasn't doable in this venue, but I wanted to hit some of the high points. And three of the things that he found in his summary that goes along with what we're trying to explain is that the concentration average of at least 4 to 5 times the head grade ore, and as you saw in the earlier charts, it can be actually much greater than that. And he noted in his summary an average of results from 18 test runs. And these weren't the ones in the chart. These were ones that they generated. It was a test protocol for us to follow. And his 18 test samples produced concentrates with nearly 4 times the average head grade ore. He also said that this process shows real potential for reduced permitting requirements. The reasons for that, I've highlighted, it's dry separation. It's a dry separation process. It's not wet. With good dust control, So you kill two birds with one stone. And the fact that it's a physical separation, potentially allowing for operations with reduced permitting requirements and minimal water demands. Big deals a lot of times. We've had mines held up for years. We have one right in Tucson that still hasn't been allowed, and most of it's due to environmental and water. The impact on local water has really been holding that mine up and may never open. The advantage over competitive dry separation devices, and his comment was that the size separation capabilities could create an added competitive advantage. Not just the fact that we can separate, but that we can do it by size as well. That pretty much concludes our presentation, at least the slide portion. We'd be happy to answer questions to the extent we can. And anyone wanting additional information can contact us through our website at www.ldmrefining.com. It's on this slide. I'm sure Charles can make this information available to you. Thank you again, Charles and CME, for setting up this opportunity. And I hope it was of some interest to those attending. At this point, are there any questions?
Yes, thank you so much, Ken, for the presentation. Unfortunately, guys, we're sort of running out of time completely, and I wanted just to thank our guests who may have to leave right away. And what I'm going to do is I'm going to read out some questions, and if anybody has to go, please note that I will be sending you a copy of the slide deck and presentation, the recording as well, so you won't miss anything. So how about we just dive into a couple of questions here? So the first question I have here is, how much is the energy consumption per ton processed?
I'm sorry, what was that again?
Yeah, how much is the energy consumption per ton processed using the LDM process?
Very good question. And I was going to include some of that information because the Cometco report really zeroes in on energy consumption per ton. And there was just no way to summarize it. It goes into quite a bit of detail. I would suggest, though, the information is there, and the investigator did an exhaustive research onto quantifying the energy requirements for a typical size operation. So if anyone's interested in actually looking at that and getting the full review, it's outlined in that.
Very good, very good. All right, okay, another question here is, what is the optimum particle size needed for this process to work?
Ideally, we'd like to be separating in the 60 to 30 mesh range. We do separations for other industries in up to 12, sometimes 10 mesh. And we can also separate down to 80 mesh. But optimum, if we can stay in the 60 to 30 mesh range, we can be very, very accurate.
Okay. All right. Thank you for that question, for that answer, sorry. Okay, the next question is about specific gravity. And the question is, what is the optimal specific gravity difference between ore and waste for the process to work?
Well, that's a great question. And let me say this. Obviously, the greater the difference, the easier it is, and the more efficient we're going to be, and the faster we can process. I mean, it all plays off each other. We can be very, very accurate at a very slow feed rate. We can be pretty accurate at a moderate feed rate. The feed rates that I've shown in my chart are a reasonable feed rate where we were getting good results and so on. So that's why we've used those numbers.
Okay.
But when you're separating gold, free gold, for instance, from silica, it's a no-brainer. I mean, you can run that stuff through there as fast as you can feed it and get much higher feed rates than what we were seeing. But there's not a lot of demand for free gold separation. I can tell you we're separating in the plastics, in one plastics application, we're separating particle sizes between 30 mesh and 60 mesh from similar particle sizes, and this is a plastic, specifically a lucite thermoplastic material, and we're separating that from essentially silica type material, and we're able to get to the point where we can drop almost nothing but the silica and process all the plastic through at least a 90% rate. When they're running that really fast, if they increase their range of recovery, it's a recovery operation, reclaim operation. You know, we may be 80% efficient, but and those specific gravities are less than 1. We're separating a 2.6 silica from about 1.6, so it's about 1. So it's pretty close.
Okay. All right. Thank you. Guys, we do have a few other questions, but what we're going to do is we're going to take those questions offline and provide answers in writing. And all these answers are going to be provided to everybody that registered for the webinar. We are about 6 minutes over, and I wanted just to end it here as people have other engagements to attend to. But I wanted to just thank everybody for coming on the call, and we look forward to re-engaging with all of you as we give you those additional slides and answers to these questions, and also access to the recording so that you can re-watch this presentation. So thank you very much, everybody, and have yourself a wonderful day.
Thank you all.
Bye-bye for now.
Thanks, everyone.
Thank you.